This chapter introduces the arithmetic operators and working with arithmetic expressions in Java. We're going to begin this lesson by going over the operators that are used to perform arithmetic. So open up a DOS window, navigate to your Java subdirectory, and then open a new class file. We'll call this one operators.java. We type public class operators, public static void main, string args, and let's close off two definitions here and then move back into the middle. So let's begin with addition. The addition operator is the plus sign. So when we want to add two numbers or two expressions together, we simply use the plus sign in between them like so. So let's compile and run this program, although it's pretty obvious what the answer is going to be. We're going to type javac operators.java and then Java operators, and we get 4. Let's move back to our program. Let's create a couple of variables. Int num1, num2. Num1 equals 120. Num2 equals 23. To perform subtraction, we use the minus sign or the dash. So let's perform subtraction on num1 and num2. So we'll subtract num2 from num1, like so. Save the file. Back to our DOS prompt. Compile. And then run. And we see the answer is 97. Back to our program. The next operator is the multiplication operator. The multiplication operator is the asterisk or the star. A lot of people say star rather than asterisk because it's a little bit easier to say. I have to agree with them on that. So let's save the file. Bring back the DOS prompt. Compile and run. And 120 times 23 is 2,760. Next up is division. So now we're going to take the value of num1 and divide it by the value of num2. So we're dividing 120 by 23. Save the file. Back to the DOS prompt. Compile it. Run it. And we see that the compiler gave us an answer of 5. Now, I don't know exactly what 120 divided by 23 is, but I know that it is not 5 even. So something's wrong. Let's take a look at the program. The problem is that right here we are working with two integer values. So an integer divided by an integer yields an integer value. We're going to talk more about mixing data types in another lesson in this chapter, but here's a good indication of what happens when you're not careful about that. So if I change the expression to read 120 divided by 23.0, now I'm dividing an integer value by a floating point value, or a double, and now I should get a floating point result. So let's save the file, go back to the prompt, compile the program again, and then run it, and sure, there I get it. 5.21739 and so on, or 5.22 approximately. So there you see an example of where you have to be careful about the data types that you use when you're expecting a certain result. And we'll talk more about that later in this chapter. The last operator I want to talk about in this section is the remainder operator or the modulus operator. Let's look at this example right here. 4 mod 3 or 4 modulus 3 or 4 remainder 3. When we use the modulus operator, we're looking for the remainder of the operation. So in an example like this where 3 will not divide evenly into 4, there will be a remainder of 1. Some people have to really think back to their long division days to remember that. Let's compile and run it. First we'll save. Then we'll run. And indeed, the result is 1. 4 remainder 3 yields a value of 1. Let's do one more using the modulus operator. Do an even value where there won't be a remainder just to see what happens. We'll stick with these small numbers. We'll do 4 mod 2. Compile and run. And now we see the result is 0. Looking at the program again, we can see that 4 is divided by 2 evenly, or 2 divides into 4 evenly with no remainder. So that's why the result of that expression was 0. Later on in the course, we'll look at situations and scenarios where using the modulus operator can be useful. But for now, just understand that it is an arithmetic operator available to you. So to summarize, we've looked at 5 operators that are the standard arithmetic operators in Java. Addition is the plus sign, subtraction is the dash or the minus sign, multiplication is the asterisk or the star, division is the /, and remainder is the % sign. When Java evaluates an arithmetic expression, it follows a particular order of operations when it evaluates sub-expressions. That order is multiplication and division followed by addition and subtraction. Let me give you an example. Let's create a variable and assign it an arithmetic expression as its value, 3 plus 4 times 5. Now let's display that so we can see what the compiler assigns to number. Before I compile and run this, let's guess what it's going to be. If you followed a strict left to right order of operations, you would say that the 3 and the 4 are added together to give 7, and then the 5 is multiplied by that 7 to give 35. However, if you follow the order of operations of the compiler, it's going to perform the multiplication first, 4 times 5, and then add 3 to that. So let's see what we get. Save the file, then compile it, and then run it. And we see that we do get 23. And again, that's because the compiler followed the order of operations where multiplication is performed before addition. If we want to modify that order of operations, all we have to do is put parentheses around those sub-expressions that we want evaluated first. So for this example, if we want the result to be 35, in other words, if we want the 3 and the 4 to be added together first before the multiplication, then all we do is put parentheses around the 3 and the 4, and then we can run the program again. So let's save it, recompile, run it again, and there we see that the result is 35. Strictly speaking, the actual order of operations in Java is parentheses, then exponentiation, then multiplication, division, and addition and subtraction. So we already see that the parentheses have a higher order of precedence than multiplication. Because the parentheses were placed around the 3 and the 4, the addition was performed before the multiplication. We don't have an exponent or an exponentiation operator in Java, so we really can't count that or even demonstrate how it works. We're going to look at how to do exponentiation in another lesson in this chapter when we talk about the math library. So actually, for our purposes, the order of operations is parentheses, multiplication, division, and then addition and subtraction when we're talking just about the operators. Later I'll show you how we can work the exponentiation function into this discussion. Let's look at one more example. Let's say that we wanted to perform a division of 2 sub-expressions and then assign that to number. So for example, we might want 10 minus 2 divided by 14 plus 3. Now, first of all, the one problem I see with that is this is going to lead to a fractional result. So one thing I need to do is I need to change my data type to double. And the other thing I need to do to make this work correctly, I need to make at least one number in each part of this expression be a floating point number. Now, if we run this program as is, it's going to perform the division first, 2 divided by 14, then subtract that result, and then add 3. That's not what we want to do. We want the numerator divided by the denominator, so what we have to do is we put parentheses around the whole numerator sub-expression, and then parentheses around the denominator sub-expression. Let's save and compile, and then run it, and you see we get 0.4705, and so on. In the exercises at the end of this chapter, we're going to enter more formulas for practice, and we'll demonstrate more about how the order of operations works. But this was a brief overview to just get you comfortable with the idea that there is an order of operations for the arithmetic operators, and the compiler follows them strictly. When writing Java programs, one of the things you'll be doing quite often is creating variables that never change in value throughout the life of the program, and also have some type of special meaning in your program. When you have a variable of that type, what you really want to do is create something called a constant, or in Java terms, a final variable. And by final, that just means that it's the final value that the variable can have. Most programming languages use the term constant, but Java picked final instead. So let's talk about how to create finals and why they're useful. When you want to create a final variable, you use the keyword final first, followed by the data type, the name of the variable, the assignment operator equal, and the value that you want to assign to that final. Because the final cannot be changed, you have to assign its value at the time you declare it. Otherwise, it wouldn't be a final, or you can't change it and it would be a default value. And actually, without a value, the compiler will give you an error saying that you didn't declare that final variable correctly. It's long been a tradition in programming to create finals in all caps, so that the final pi would have been written capital P, capital I. That makes it stand out in a program where every other variable and other types of objects are in lowercase. That's not so much a style anymore, and I don't follow it in this course, so we're going to create our finals in lowercase just like any other identifier or object type that we create, except of course for a class, which has to start with a capital letter. Once you've declared a final, then you can use it just like any other variable. So we can compute the area of a circle using pi like so. And notice how I use parentheses to group radius times radius together, so that operation is performed before we multiply it by pi. And then we can compile that and run it to see what the result is, but I'm going to skip that step here because it's really not that important. What I'm trying to show you is how to use finals, not so much what we get when we use them. We'll look at those kinds of things later. So once I've declared pi, I will show you this though. Once I've declared pi, if I try to change its value, let's say, we're going to sneak it up a little bit and we'll say it's 1.5, or let's say it's 142. If I try to compile and run this program, watch what we're going to get. So I named it final, so we're going to say javac final.java. Cannot assign a value to final variable pi. So there's the protection you have from the compiler when you create a final variable. Its value cannot be changed. And that's why we create finals, so that their values stay the same. Only use final when you have a special value. Some people call them magic values. But a special value that you don't want to change. For example, pi is always going to be 3.14159 or whatever value you want to use for pi. There's no reason any time in the program for it to change. So that's the perfect candidate to be declared as a final. Radius, on the other hand, might change if we look at a different circle or if the size of the circle gets larger. The radius doesn't make sense as a final, nor does area, but pi is perfect for that. In a string example, you might have a string variable called greeting that always is hello. So that you might use it in concatenating a string with hello John or hello Mary or whoever you're going to send a greeting to. But if that value is never going to change and you don't want it to change, especially accidentally, then you want to put final before that, like so. Now greeting will always be hello and it cannot be changed. So finals are not necessary components of a program, but they can help make your program easier to read and easier to maintain, because once you've set the value for a final, then you know that it can't ever change. And that's about all there is to say about finals. We'll use them occasionally in programs, but mostly I just wanted you to be aware that when you see finals in Java code that you read, what the code is doing with those identifiers. They're setting them up to be a value that can never change. In the next lesson, we're going to look at some uses of the Java math library. There's several functions that are not built into Java, like square root and absolute value, and you find those in the math library, and we're going to take a look at that in the next lesson.